Hello and welcome to the Undet Toolbox version 2 features video series. In this video I will present SmartBoard. SmartBoard is a new navigation modeling method for fast and easy point cloud profiling, automated section extraction and 3D modeling. SmartBoard divides drawing window into 3 different viewports. 2 viewports, front and top views, are dedicated for navigation and control, and the 3rd viewport is dedicated for drafting only and is called Drafting Viewport. Drafting viewport hides unnecessary and disturbing background information such as confusing point cloud drawing elements and shows only defined thickness profile of the sliced point cloud. Besides, SmartBoard automatically sets up and tracks drafting plane, which is called UCS in AutoCAD. So let's go into AutoCAD environment and see what's so smart about the SmartBoard. I have opened here a point cloud project of an old Japanese arbor. It is a heritage object. See how it looks like. And at the beginning I'll show you how to turn on and off the SmartBoard, how to navigate in it, how to create different point cloud profiles and sections, and later on I'll show you how to extract some features out of it for 2D drawings and for 3D modeling. Right, so if you would like to turn on the SmartBoard, click on the SmartBoard icon over here in the ribbon menu. And as you see, your window will be divided into 3 different viewports. Just zoom to extend if the view jumps somewhere. The front viewport and the top viewport, and the biggest viewport is your drafting board. So you will see the profile of the point cloud over here. And you will also have a new dialog box appeared when activating the SmartBoard, which has some features for point cloud sectioning and profiling, some more features for sectioning, some other stuff about I'm going to talk a little bit later. You also have a field to define section thickness and an offset step field. You can also define, so let's create a first section of this structure, and I'll use this simple cross section feature over here. Just choose the viewport, and you can choose any to define this section plane. I'll choose this one by clicking on the viewport and then defining the line like this, which will generate a slicing plane through the point cloud. And you see I have here my section already of 10 centimeters, and I see those 6 columns crossed by this plane. Now you can move it up and down according to the Z-axis of the UCS. It was created newly, and the UCS will be tracked when I will move my slicing plane up and down according to the Z-axis. So let's move it up, and you see a different profile appearing in the drafting plane over here. You can increase the step, let's say if you would like to ½ meter, and move it into another direction. You can also move the plane manually. Just choose the arrow and drag and drop where you want to have this section of the point cloud. So I have now this upper part sliced, and I see this section of it. Let's recognize the circle. Simply choose Auto Circle feature from the ribbon menu and click somewhere on it, and you have your circle recognized. Let's say you would like to recognize this wooden beam. We have 6 of those, 1, 2, 3, 4, 5, 6, and it has a bit different profile over here. It's hard to see now, so let's try to create a profile section of this wooden beam. I'll show you the workflow how to do it. So at the beginning you need to choose the same cross section feature over here. I'll just work in this viewport now and simply create a section that will pass by this wooden beam exactly on the middle of it. Yep, so I have a plane crossing my point cloud like this. See the view from here. Let's activate this plane, and you see how it looks like in the drafting board over here. And I know that this is the wooden beam I want to investigate. I'll choose now another feature which is called profile section over here, and this will create a perpendicular section to this line I'm going to define right now, and this section is going to pass by the first point I have defined over here. So it's going to be perpendicular to this line, and I know that I will create a profile section of this wooden beam. So let's define like this. So see, the plane is crossing the wooden beam exactly perpendicularly, and I have this section of it in my drafting board. Okay, let's recognize another circle over here. See, we also have some profile. You can use also native AutoCAD tools. So to draw the profile of the point cloud, I'll do it very approximately over here. Let's turn off the point cloud for a moment, turn off the snapping. So like this. Yep. You can also now use the native tools to extrude this 3D object. So let's extrude it to the center of the recognized upper part. And you can also now use, let's say, native tool like array, polar. Yep. Let's select this object and let's define base point, which is going to be over here. But just prior, I need to set the UCS to the world UCS. Once again, choose array polar and define the center to array. Okay, so we see I have just extracted one wooden beam with this profile and just arrayed it around the structure. Let's see how it looks like in the point cloud. Well, I just assume that the angle is the same everywhere. I see that it's not the same, exactly the same angle, but just for demonstration purpose, it is good enough. Let's create another profile of this point cloud, and let's extract some features. Let's say like these walls. So I'll choose again the car section feature over here. Just click it like that. We have our car section. Let's recognize some box, and let's recognize some actual or adjusted. So the difference is that if the point cloud box is going to be leaning, so the extracted box, if it's going to be chosen as an actual, is going to be leaning as well. If you will choose adjusted, it will be vertical and it is not going to be leaning. Let's simply click on the point over here somewhere and point over here somewhere. Let's turn off the point cloud for a moment. See my extracted box. I'll turn on the point cloud, and it was extracted pretty precisely. Why it stopped over here? Because it is not already a box, it is a cylinder over here. And if you want to confirm this, let's create another profile section. I'll use now left to surface feature over here, so it will create a vertical section like this simply by picking up a point, and I will have a view from the left. So I'll choose this feature and simply pick a point somewhere on this, I assumed a cylinder structure. So see, I just crossed this wall like this, and I have my profile of it, and really my wall stopped over here because this is already a cylinder, not the box, so that's why the box stopped over here. Okay, let's recognize the cylinder. Let's choose cylinder actual, so simply click on it. Yep, so my cylinder is recognized. I can also, say, click on this cylinder and recognize this one as well. This cylinder is also recognized. So in this way you can create sections of the point cloud investigate the situation all through viewports and proceed some 3D modeling. I'm not going to recognize all other walls because the workflow is the same. Let's move to another point cloud project and I'll show you some more features of the SmartBoard. Just for the end, if you would like to come back to the original point cloud and turn off the SmartBoard, simply click again on this SmartBoard on-off button icon, or on this cross over here, close the SmartBoard, and you are back to your original point cloud. I have opened another point cloud project in which I'm going to show you how to fast and easily extract 2D plan drawings of this scan flat. Let's turn on the SmartBoard over here and let's create a section that will pass by entire flat, and I have the plan view which looks like this. And I'll use now automatic feature extraction auto line functionality, simply clicking somewhere close to the line to automatically extract it like this, so like this and this and this. And then you have the possibility to close this polyline. Press enter, choose if you want to close yes, and enter the fuse distance, let's say 5 meters. As you have my polyline closed and I have extracted my drawing lines very precisely, even though there was some missing information in the cross section. Due to that, because it was only one scanning position in the middle and there were disturbing objects as furnitures and so on inside the interior. Okay. Let's check what we have more over here. So this is align view section feature, and let's say if you would like to put this section, cross section of this point cloud into your view section list, you can simply select this option and another view section appears. Let's turn off the SmartBoard and we have active view section. So we have just created this view section from the point cloud and it looks like this. Yeah, let's deactivate it. And you can also combine two navigation methods of the Undet toolbox together. So SmartBoard together with the true view mode. And let's say you need to choose one of this smaller viewport to activate the true view in. And let's say I'll choose the lower one, click on the scanning position with the right mouse button, press true view, and this way you can activate true view mode in one of the viewports. And if you would like to know more about the true view, check our video tutorial talking about true view navigation and its synergy with automated feature extraction. So we will see more information talking about it over there. But basically it's possible to combine these two modes and have the synergy together, working at SmartBoard, profiling and seeing the view from the scanner eye, exactly where the scanner captured the scan data. Right. We also have irregular profile creation, and I would like to show this in more details in another point cloud project, which will be more convenient for such task. Over here we have a point cloud project of an old train bridge. In fact, there is no bridge deck left anymore, as you see only some ruins in left and right river banks. And in the right river bank we also have an interesting object. It is leftover of this old train bridge abutment, and I'll cut it out. I'll show you how to use automated features in order to extract irregular shape profiles out of such an extraordinary shape objects. And we'll do it in SmartBoard, so let's turn it on. For the beginning, I'll slice this abutment with the cross-section feature, the thickness 5 cm, and let's define the area of this section plane somewhere in between bricks like this. So here is the section view, and now let's simply click on the icon of the regular profile to vectorize the section. It is vectorized. Let's turn off the point cloud, and as you see, it was vectorized pretty nicely. Only some trashes were taken into account as well, so we can still redefine some parameters over here. So let's redefine the area using polygons in order to vectorize section which is within this area. And we can also play a little bit with other parameters like decimation, which is very important. So let's say if I would choose 0, the minimum value, now every point will be taken into consideration, and as you see, the lines are very wavy, lots of small segments. And if I would choose now the maximum value of 10, only very few points are taken into consideration of this vectorization, and very few lines were generated. But at the same time, we have much bigger error of this profile. So let's choose the value which is closer to 0, so something like 3. And over here, it is a pretty nicely vectorized point cloud section, and let's say it works for me fine. Let's turn off the point cloud to double check it. It is good. You can also change some values for joining gaps, for length, for segment length. Let's say it was 0.2, so the minimum segment length is 20 cm. Let's keep it like this. The resolution value, so this is basically about your precision. So it is the tolerance, the error, it is half of this value, so 6 cm, so it would be 3 cm. Let's make it 0.4, so my tolerance now would be 2 cm. And just before, you need to turn on the point cloud to define this value. Okay, 0.4 centimeters. It is nothing changing in general, so it is good enough. And let's accept it as our profile. Let's turn on the point cloud again, and let's activate the look of this section plane, and let's move it a little bit up into a next level. Let's say somewhere here, again in between the bricks, and we have a view which looks like that. Once again, let's click on the irregular profile feature to generate this irregular profile. Let's turn off the point cloud, see how it looks like. See, I have some trashes over here. Maybe let's play a little bit with the decimation. Let's choose 4, or maybe let's keep it 3. It was good enough. Let's accept it, but let's just play a little bit with this profile in order to join this together. This is a more proper look, right? So let's turn off the SmartBoard right now, and you see we have 2 sections out of this object, and we could create even more. So we already have 2D drawings of this regular shape object. If you want, you can even loft them and create a 3D solid. So simply use the loft feature, select those 2 sections, press enter and accept it. This is how the lofted profiles look like together. So this is what I wanted to show you regarding the regular profile creation, which is a very nice feature if you're dealing a lot with irregular shape objects, if you need to extract 2D drawings out of them or generate 3D models. And I'm done with the SmartBoard tutorial. Thanks for watching video.